All right, let's go on. That third example will be done in class. Let's go on to our second version or variation of our difference of means test. The formula that we're going to be using here is T equals, and it looks the same, except that our standard deviations now are sample standard deviations. And we'll be using it exactly the same way. I do want to mark up our formula like we do every time we introduce one. Now, the important thing to notice is that we're going to use this version of our formula when we have n's that are both smaller than 30. Because it is a t-test, that's indicated by the letter out in front, and this is what's going to be in our hypothesis. But because it is a t-test, we do need degrees of freedom, and that is on your formula sheet. We want to use the smaller of n1 minus 1 and n2 minus 1. And we'll illustrate that in the two examples that we're going to do. Let's look at our first example. A study was conducted comparing college majors to that require, a study was conducted comparing college majors that required 12 or more hours of math to majors that required less than 12 hours of math. The mean income of 8 majors requiring more than 12 hours of math was $45,692 per year, with a standard deviation of 1,236. The mean income of 10 majors that require less than 12 hours of math was $40,416, with a standard deviation of 5,324. Test to see if there is a difference in the incomes at a 0.01 level. These don't sound any different than what we did on the first test because they're not. The only difference will be our table, but first let's write down what we're looking at. We're going to start off with majors that require more than 12 hours of math. They were mentioned first, so that's going to be our first sample. To those that require less than 12 hours of math. The first sample had the mean income of 8 majors requiring more than 12 hours. So N1 is 8. And their mean income was $45,692 with a standard deviation of 1,236. The mean income of 10 majors with less than 12 hours of math, that's sample number 2, had a mean income of $40,416 with a standard deviation of 5,324. Test to see if there's a difference in the incomes at an alpha of 0.01. Okay, so I'm going to start off by writing the mu's down so that we can compare the two means. Is there a difference? That means they're not equal. That's going to provide us with our alternative hypothesis. Mu1 minus mu2 is not equal to 0. Because that's our alternative, the null will be that mu1 minus mu2 equals 0. It is a difference of means test with n's that are both smaller than 30, so it is a t-test. It is also, because of the alternative hypothesis, a two-tail test. Let's find our critical value, our obtained value, and our conclusion. Now, because it is a t-test, and that's determined by our two sample sizes being less than 30, we're going to look, and it says degrees of freedom is going to be found by using the smaller of n1 minus 1 and n2 minus 1. Because our n1 is smaller, 8 minus 1 would be 7 degrees of freedom. Now, the t-test is the cool one. He does everything for you. So if you will intersect on your t-distribution table 7 degrees of freedom, and at the top 2 tails with an alpha of 0.01, you should find plus and minus 3.499. It is plus and minus because it is a two-tail test. And again, in class, we'll go through it a little bit slower and we will elaborate a little bit more. Let's see, obtain value. Of course, we're going to plug into our formula. It is a t-distribution, so t equals 45,692 minus 40,416 minus 0. We don't need to write that though. Over the square root, let's see, since they gave me standard deviations again, I will square them myself. And again, pause the video if you need to be able to calculate that yourself. You should get 3.033. When we plot that, it does fall in the open area, doesn't it? Because it falls in the open area, we're going to accept h sub 0. That means we have to write what the null hypothesis says, but not before we put it back into a form where we can make the comparison. Move the mu sub 2 back over to the other side. And what do we know now about the average incomes of majors with more than 12 hours of math versus majors with less than 12 hours of math? It's about the same. So we can write the average or mean income of majors with more than 12 hours of math is the same as that of majors with less than 12 hours of math. All right, let's go ahead and look at example number 2. It says 2 different models of cars were tested for gas mileage. Test the claim that the models have the same gas mileage at the 0.05 level of significance. Okay, so we have model A and model B. Because they listed the information for us and we didn't have to list it ourselves. The first one provided is sample 1. The second one provided is sample 2. In making the comparison of their gas mileages, it does say test the claim that the models have the same gas mileage. That's equal again, isn't it? After moving the mu sub 2 back over to the left, it does give us our null hypothesis. mu1 minus mu2 equals 0. Because that's a null, the alternative will be that mu1 minus mu2 is not equal to 0. Because I'm testing a difference of 2 means, I know that it is going to look like a normal distribution, but this one is a t. Why? Because my n's are both smaller than 30. I'm going to go ahead and find my degrees of freedom. Take the smaller n and subtract 1. So we're going to be working with 8 degrees of freedom. According to our alternative hypothesis, it is a two-tailed test. So we're going to use our t-distribution table to find our 2 critical values. Remember, the t-distribution is the nice one. He does everything. So go up to the top. In the row labeled 2 tails, go over to alpha equals 0.05 and intersect that with 8 degrees of freedom. You should find plus and minus 2.306. Now the plus or minus is because of the 2 tails. For the obtained value, we're going to plug into our formula. T equals 28.6 minus 32.1 over, and again, they gave us standard deviation, so I'll square them myself. And put that into the calculator, and again, pause the video if you need to. You should get 2.356. That is why it's so important to keep 3 decimal places. That one just barely falls in the shaded region, doesn't it? So because it fell in the shaded region, we're going to reject the null hypothesis. That means we agree with the alternative. Before you can write the conclusion, though, you do need to move your mu sub 2 over to the other side. So I need to write this. Mu sub 1 is not equal to mu sub 2. Well, the average gas mileage of Model A is not the same as the average gas mileage of Model B. The gas mileage of Model A is not the same as the gas mileage of Model B. All right, I'll see you in the next video.